All right, guys, so today we're going to start up U-Substitution. This is a different way that we actually use to integrate certain problems, especially when we're not able to use either the step-up rule or just look at a trig function or an exponential function or something of that sort that we haven't been able to do. And U-Substitution is basically just looking at the chain rule backwards, and I'm going to go through a couple examples with it, so hopefully you get a little bit comfortable with that as well. But kind of the first thing is our rule for U-substitution. So if we're integrating something where we have f of g of x times g prime of x, and once you see an example, it'll make a little bit more sense. But if we have f of g of x times g prime of x, notice that this is basically just the chain rule. And the only thing that's a little bit different with it is that we don't have this f prime of g of x, which is okay. Once you kind of see what we'll be doing, it's kind of looking at doing the chain rule backwards. So that's why we don't have that derivative inside there, because it's just a function and then we're deriving whatever's on the inside of the g of x. And you'll be able to kind of go through and see as we go through and do it. But what we're actually going to do is we're going to use this substitution. We call this the U-substitution, where we're going to make u equal to g of x. Notice g of x is kind of the thing on the inside of the function. And so that du is equal to gx dx. And how we get that is just derive both sides. You get du dx is equal to g prime of x. Oh, sorry, that's supposed to be g prime of x over here. Okay, so, and then if you just multiply both sides by dx, you just end up getting what that is. Okay, so we use this substitution in the sense of, whenever we see something that's kind of like the chain rule, we haven't been able to use the step down or step up rule in these senses. We've been expanding it. So something that's might be kind of simple, just a easy kind of way to look at it is if I have 2 times 2x minus 3 to the 5th power, and I want to integrate this. What you could do is you could multiply 2x minus 3 by itself 5 times and go through and integrate it that way. You would end up with the same answer, and that's fine. But if you want to make it a little bit easier, something that we know is that we can actually still use the step up rule, but the reason why we can't use it right now is because on the inside here we don't just have a derivative that's equal to 1. So what we want to do is we want to use some people call it the reverse chain rule, but U-substitution in this sense, where our u value is going to be the value that's on the inside, just like how I set up here. So it's going to be 2x minus 3. And so your du is equal to 2 dx. Okay, so it's du dx is equal to 2, so then you multiply both sides, but you'll kind of get used to just writing that dx on the right side. So if I went through and just substituted, if my 2x minus 3 is a u now, so this is just 2x minus 3, I get u to the 5th, and then my 2dx is just equal to du. So now all I'm integrating is just this integral of u to the 5th, which we know is u to the 6th divided by 6 plus c, which then is just equal to, if my u is equal to 2x minus 3, 2x minus 3 to the 6th power over 6 plus c. Okay, so that's how you can kind of go through and see those specific values. And that makes sense because if you went through and you derived this, you would end up just with what we started with. The 6's would cancel, and then you would have to use the chain rule, multiply by 2, the c would go away in that type of sense. Let's look at another one. So if I said, let's go with something like any type of integral that has to do with the chain rule. So if we have 1 plus the tangent of theta to the 5th power times the secant squared of theta d theta. And so if we went through and did this, if you notice, if I derive this inside part, I get what's on the outside. And that's kind of one of the keys to be able to look at and see that you're going to be using U-substitution. So if we just look at doing this, then we would have, we would want our u value to equal 1 plus the tangent of theta. So our du is equal to the secant squared of theta. because the derivative of 1 is 0, and the derivative of the tangent is the secant squared, so it would be du is equal to secant squared of theta d theta, which is nice because that's inside here. So this is just equal to du, and this 1 plus the tangent of theta is equal to u. So this is just then equal to the integral of u to the 5th du. And so then this would be u to the 6th over 6 plus c. Don't forget the plus c, the constant. So this would equal 1 plus the tangent of theta to the 6th power over 6 plus c. And that would be the integral using the U substitution in this type of sense. Okay, let's look at another one. If I said, let's look and say we had something like the integral of the cosine of theta over the sine squared of theta and d theta. And if you look on the notes, I actually went through and made it a definite integral. I'm just going to go through just a regular integration of this. Our U substitution here, our U substitution, we're going to make our U in this case. So now we have to kind of think what's kind of like the inside part of this. Well, the inside part is really this right here, because it's really the sine of theta squared is the same thing. So I'm going to make my U just equal to the sine of theta d theta. And you usually want to use, especially with trig functions, the value that has the largest exponent with it. So here we have the squared. Just kind of a little tip as you go through and do it. But then our du would equal the cosine of theta d theta, which is nice because we have that. That's right there. So we end up with the integral of just du. So 1's on the top, and then on the bottom we have the sine of theta squared. Well, the sine of theta, this d theta is not supposed to be there. We just have the sine of theta is equal to u, so you would just have u squared. So this is equal to the integral of u to the negative 2nd du, which is equal to u to the negative 1st over negative 1, just step up rule, plus c. And so my u value is just equal to the sine of theta, so we get the sine of theta to the negative 1 power, and I'm going to negate it because of this negative 1 plus c. So this is really equal. You could box that. I'm fine with that if you left that as an answer. But this is also equal to the negative cosecant of theta plus c. And we know that because this is just the reciprocal. This negative 1 makes it the reciprocal. Remember, it's not the inverse here. It's the reciprocal as you go through and look at that. And I'll do one more, last one. If I look at the integral of the natural log squared of x over x dx, and I'm looking at integrating this. So think of what's on the inside. Well, we have this squared, so we think that, okay, well, this is the natural log of x squared. So I'm going to make my u value equal to just the natural log of x. So my du is equal to 1 over x dx, which is nice because we have the 1 over x right there. So if we take this 1 over x dx, this is just equal to my du. So this is now equal to the integral of the natural log is squared, so that's just our u. So this is just going to be u squared du. Notice this x dx go away, and that just becomes du right there. So this is going to be u to the 3rd over 3 plus c, which is then equal to, my u is the natural log of x, so natural log of x to the 3rd power divided by 3 plus c, and that would be my indefinite integral. Okay, so if you go through those notes, there's a couple more examples to kind of maybe go through and help you out. I'm going to go through another way that we can go through and look at U substitution next week. And that kind of includes, well, what happens if there's a constant that goes along with it? Well, that's kind of simple. You just kind of multiply on the inside. If you look at the last problem on the notes, that's a good kind of start to it. But I just kind of want you guys to see that as you go through and do it. So if you guys don't have any questions, or if you do have any questions, please let me know. We can hop on a Google Hangout. You'll have a question or two like this on your quiz for Friday. So just let me know, and you guys